The lithium problem. The seventh nucleon of the lithium-7 nucleus has only 3 unit bonds, while the others have at least 5. Here is why. Summary. The Big Bang model describing nucleosynthesis predicts an abundance of lithium-7 and a certain amount of lithium-6. But the amount of the lithium-7 is 3 times too high compared to that observed in stars, while the amount of lithium-6 is too low compared to the observed amount. The standard model, SM, of particles cannot explain these differences. The structure of the lithium-7 nucleus according to SM. The proton has a positive charge. The neutron is neutral. The right picture represents the lithium-7 structure. The structure of the lithium-7 core according to XM. There is a non-standard model, Xeridon model, XM. The following section will present in detail the structure of lithium-7, including neutrinos, quarks, and nucleons. Pure negative electric charge is represented as a void sphere, and the pure positive electric charge is a red sphere. A pure electric charge captures a photon, which remains trapped within the charge's cavity. The electric charge will rotate with the photon's motion. Here is an electron. The positron has the same structure. A pure electric charge captures a photon. Structure of a neutrino according to XM. A positron and an electron made a system in rotation with a speed v. This structure is called a charge net. It is modeled by a disk, like a yin and yang symbol. Indeed, there are different energy levels for the charge net depending on the v speed. The rotation of the charge nets results in electrical neutrality. Structure of an up quark according to Xm. Three charge nets form a stable triangular chain. This stability is ensured by the electrical force at the 3 points of the contact of the three charge nets. The green charge net has an orbital velocity of 3v. This structure without a positron is called a chrominate up. This compound particle is electrically neutral. This structure with a positron is called an up quark. This composite particle has an electric charge E+. Structure of a down quark according to Xm. With a different level of energy, three charge nets form a stable triangular chain, like before. The blue-orange charge net has an orbital velocity v. This electron-free structure is called a chrominate down. This compound particle is electrically neutral. This structure with an electron is called a down quark. This composite particle has an electric charge E-. Structure of a neutron according to Xm. Starting with an up quark called the core, the construction continues with the same principle as a quark on its three sides. This results in a neutron. There are two down quarks and one up quark at the periphery. The electrical balance is 0. Representation of the neutron according to Xm. The neutron has an axis of symmetry that passes through the center of the core and is parallel to the three charge nets of the core. The view along this axis can be represented by the diagram opposite. Structure of a proton according to Xm. Starting with a down chrominate called the core, the construction continues with the same principle as a quark on its three sides. This results in a proton. There are two up quarks and one down quark at the periphery. The electrical balance is E+. Representation of the proton according to Xm. The proton has an axis of symmetry that passes through the center of the core and is parallel to the three charge nets of the core. The view along this axis can be represented by the diagram opposite. Structure of a deuterium nucleus according to XM. The deuterium nucleus consists of a proton and a neutron. Disregarding the position in the neutron's core, the distribution of electric charge in the neutron is symmetrical to that of the proton. This E plus E minus symmetry naturally creates three electrical bonds through the Coulomb force. Structure of a tritium nucleus according to XM. The tritium nucleus consists of one proton and two neutrons. Starting with deuterium, the second neutron is symmetrical to the first. The bonds are the same as those of deuterium. Structure of a helium nucleus according to XM. The helium nucleus consists of three protons and three neutrons. Starting with two deuterium nucleus, they are placed in parallel so that their axes are opposite. The bonds between them are in four groups of E plus E minus. Structure of a lithium-7 nucleus according to XM. Here is a second version of the lithium-7 core. Explanation of the lithium-7 problem. Due to its geometric structure, lithium-7 very easily loses its seventh nucleon, the last neutron, which becomes lithium-6. During the fusion process that produces lithium-7, a significant proportion of the kinetic energy is transferred to the last neutron, which has only three elementary bonds, while the other nucleons have at least five elementary bonds. This ejects it from lithium-7. An elementary bond consists of an electron and a positron in a static position. Question: why doesn't the same phenomenon occur with tritium? Answer: the overall kinetic energy of tritium is lower than that of lithium-7, insufficient to eject the last neutron. The kinetic energy of lithium-7 is transferred to the last neutron to ensure the conservation of angular momentum before and after the fusion of lithium-7. More details can be found in internet site https://nonstandardmodel.org or http Jack's point 动 point free point fr